So let's go ahead and get started. There are basically two types of naming in chemistry, inorganic and organic. In this video, I'm going to be focusing on inorganic naming. In inorganic naming, there are basically two types of naming, ionic and covalent. Yes, I know that there's a lot of division in chemistry. Let's start with ionic just because it's easiest in my opinion. So in order to make sure you're naming things correctly, you must be able to distinguish between the two types of inorganic molecules. Here's the rule. Ionic bonds are usually made between metals and nonmetals. We will elaborate on this definition in a future video, but for now that's all you need to know. Metals are found in the left side of the periodic table to the left of the staircase. For example, Na, sodium, is a metal. A nonmetal is usually found to the right side of the periodic table to the right of the staircase. There's one exception, however, and that is hydrogen. Hydrogen can act as both a metal and a nonmetal depending on what elements are involved in the compound. When saying the name of a molecule, you say the name of the metallic element, then you say the name of the second element. With an "-ide" at the end of it. But in the case of polyatomic ions, which we'll get to in the later part of this video, you say the name of the polyatomic ion and you don't add an "-ide" to it. Remember that the number of atoms in the compound does not matter. So let's go ahead and do an example with a chemical we all know well, salt. The chemical formula for salt is NaCl, which we would pronounce as sodium chloride. Now here's an example that you can try for yourself, so pause the video if you need to take your time. The correct answer is potassium oxide. So how do we go backwards from what we say to the chemical formula? Now you know the two things in the bond, or the two types of elements in the bond, but you need to know how much of each element is in the molecule itself. And so there's an easy way to find that out. So in order to find the charge, you have to find out how many electrons in the atoms have to gain or lose in order to achieve a full octet. Metals usually lose electrons and non-metals usually gain electrons in order to fill their octets. For example, let's look at sodium chloride again. Sodium, which has a sign of Na, will lose an electron, whereas chlorine, the chlorine atom, will gain an electron because it's one away from obtaining a full octet. So then now that we know the charges of the two atoms, now we have to crisscross the charges, and so we get NaCl. So now let's move on to transition metals that have their own naming technique. This is because they have the ability to form different oxidation states, or charges, as we've talked about previously. So where are the transition metals actually located? Well, they're located right in the middle of the periodic table, starting at period 3. For most questions involving transition metals, you usually know the charge of the transition metal before you're expected to find the name or the chemical formula. So 3 elements that are exceptions to this rule are Ag, Cd, and Zn, or silver, cadmium, and zinc. So Ag always forms a 1+ charge, cadmium and zinc always form 2+ charges. Finding the chemical formula for a transition metal is the same as the normal ionic bond, but things change when we try to say the name of the chemical. For example, let's look at PbO. We know that Pb will have multiple charges since it's a transition metal, but we can crisscross the charges in the chemical above in order to find the charge of Pb. Now we know the oxygen will make a 2- charge, and so by crisscrossing the charges, we can also figure out that the Pb, or the lead atom in the molecule, will have a 2+ charge. And so in order, when we're writing the equation down, we have to use a Roman numerals next to the lead in order to indicate that the lead has a 2+ charge instead of a 3+ or 4+ or whatever else charges that it has. So as you can see, the "-ide" for the oxygen does not change. So let's do a practice one. PbO2. Pause the video if you have to. The correct answer is lead 4 oxide because when we crisscross the charges, we find out that lead has a charge of 4. With that done, let's move on to covalent naming. Covalent naming is just like ionic with one major difference. We actually have to use prefixes in order to show how many atoms of each element there are. And before I forget, don't reduce the subscripts. So here are the prefixes. You can stop the video if you need to write them down, but I'm going to move on. Now let's look at an example. Water. Water has the chemical formula of H2O. When we were naming this, we noticed that there are 2 hydrogen atoms per molecule, therefore we must use the prefix di. Now that we only have 1 oxygen, we have to use the prefix mono. Now when we combine them, we get dihydrogen monoxide. Now try naming NH3. The correct answer is nitrogen trihydride. So before we move on, here's the list of polyatomic ions that I was talking about earlier. You have to just memorize these. There's no other way of going around this. You have to memorize the name, the chemical formula, and the charge that it produces in most compounds. Write them down if you need to. Let's go back to ionic and do a practice one with a polyatomic ion. Let's look at Na2SO4. So since this is an ionic, we don't have to worry about the prefixes, therefore we can just name straight across. The answer in this case would be sodium sulfate, because sulfate is the name of the polyatomic ion that was in this molecule. So now let's go the other way. Write the chemical formula for calcium sulfate. So since this is an ionic, we must crisscross the charges. We know that Ca will usually have a 2+ charge, and so we can write that easily. But we have to remember back to the polyatomic list, and remember that sulfate ions usually form 2- charges. So now when we crisscross the charges, we get Ca2SO4 2. Don't forget the parentheses. Now since this is ionic, don't forget to reduce the subscripts. So then our final answer should be CaSO4. So with that done, let's cover acids and bases. Bases are easy because all you have to do is add hydroxide to the end of it. Acids are a little tricky, but it's easy if you just remember this table. Pause if you have to write it down. Now with the table written down, let's go ahead and look at an example, H2S. If you look at the table, you'll realize that all we have to worry about is the ending, and so since H2S ends in an "ide", we can go ahead and name it. Now looking back to the table, we can safely say that the name of H2S is hydrosulfuric acid. So that's all for this week. Next week we'll tackle organic naming. If you want some practice, find some worksheets online or look at the ingredients on some food that you eat and try to figure out the name of the chemical. And as always, I'll see you guys on the next one.